Hello everyone, welcome to this tutorial of performing factor analysis with SPSS. So before we actually start with SPSS, let me explain you the concept of factor analysis. Basically, factor analysis is a statistical technique which we use to reduce the dimension of data. That means if we have a high dimension data and we want to reduce the dimension of that data, then we can use factor analysis. Simply, if you have collected a data of say 25 different statements, through 25 different statements you have collected data related to 25 variables. Okay, it may be possible that a few variables are common in nature. That means they are reflecting upon the same construct. So there is no point of studying all these variables separately. Instead, we should club them together in one factor. Okay, so basically this technique help you to minimize your data. Initially we were having 25 variables, but on the basis of commonality between all these variables, we have clubbed them in 4 or 5 factors. Okay, so this is how we reduce the dimension of data. As you can see in the diagram, there are we have collected data through 9 questions. That means there are 9 different variables related to which we have collected the data. So now we observe that question number 1, question number 2 and question number 3, they are common in nature, they are similar in nature, and they are reflecting upon someone's numeric IQ. So instead of studying question number 1, question number 2 and 3 separately, we should club them together and create one factor, that is numeric IQ. In any of the further analysis, we will be using this single factor numeric IQ rather than these 3 questions separately. So this is how our 9 question data is reduced to 3 factors. One important advantage of reducing data is by reducing the data we can remove the problem of multicollinearity as well. Okay, like question number 1 and 2 and 3, if we read them separately, if we insert them separately in a regression, then there will be a problem, because question number 1 and 2, they are common in nature. There is a high chance that the correlation coefficient between these two variables will be on the higher side. So definitely it will result into a problem of multicollinearity. But by clubbing all the common nature variable into one factor, we have also reduced the problem of multicollinearity. Now the chances of multicollinearity between numeric IQ and other factors will be less. Okay, so for performing factor analysis, we need to take 2 steps. One is factor extraction and second is factor rotation. So before we actually discuss factor extraction and factor rotation, I just want to explain you the assumptions of factor analysis. So before we apply factor analysis, we need to see whether assumptions are fulfilled or not. So there are 2 basic assumptions of factor analysis. One which is related to sample size. Second is related to the multicollinearity between variables. That means first assumption says that sample size should be adequate, so it should be sufficient. Now what researcher think about the sample size adequacy, they actually apply KMO test. So KMO test will be used to determine whether your sample size is sufficient or not. And second assumption is of that all the variable or a majority of the variable must have or they should have a higher correlation among them, then only we can club them together. So this can be used with Bartlett test of specificity. So there are 2 tests which can be used to understand whether assumptions are fulfilled or not. So what exactly these tests explain, I will be doing it in the analysis section. Okay, so now come to the point, performing factor analysis. So for performing factor analysis, we need 2 steps. One is we need extraction, second we need rotation. Okay, so there are multiple methods of extraction. Similarly, there are multiple methods of rotation as well. Okay, the most commonly used method for rotation for extraction is principal component analysis and common factor analysis. And most of the cases when we are doing a exploratory factor analysis, we usually select principal component analysis. We call it PCA. So PCA is the most used method of extraction. Okay, so I'll also explain the concept of PCA when we will start the analysis. Okay, and then second is rotation. Rotation is simple method which we use to achieve a simple structure of data. Sometime what happened, a single variable load on two different factors. Okay, so just to avoid or just to reduce this cross loading, we actually rotate the data for achieving a simple structure. Okay, so there are two type of rotation as well, orthogonal rotation and oblique rotation. Orthogonal rotation is used when we think that factors are independent. That means they are uncorrelated. There is no correlation between factors. Then we can use orthogonal rotation. Otherwise, if we feel that our factors are correlated, then we will use oblique rotation. Although in case of principal component analysis, most of the time we use orthogonal rotation, because this is the assumption also that we try to create factors which are unrelated. So there is high chance that your factor will be unrelated. Okay, but we will check this also, whether our factors are related or they are unrelated. So this is the basic concept of factor analysis. Now we are moving with the SPSS procedure. So this is a data set, as you can see on the screen. This is a data collected through a survey. Okay, so this is a data of 459 individuals on different personality parameters. So we have asked many questions related to the personality of individuals and capture the data. Like you can see in the level, we have asked a question related whether they are talkative or not. We have asked the question related finding faults. Okay, depressed, original, relaxed, whether they are curious, whether they are full of energy. So these are different personality characteristics on which we have asked questions. So in totality, there are 44 different variables or 44 different parameters on which we have collected the data. So now as the number of variables are too much and we don't want to study them individually, because there may be possibility that few variables are highly correlated, so it will create problem in your model estimation. So what we want to reduce these 44 variable into some smaller number of factors which are uncorrelated. That means we want to club all correlated factors into correlated variables into one factor. Okay, so for this purpose we can use factor analysis. Okay, factor analysis actually before performing factor analysis, we need to check few things. We need to check for sample size, we need to check for whether variables are correlated or not, sufficiently correlated or not. So these thing we have to check. Okay, so we will do it one by one. So for applying factor analysis, just go to analyze, select dimension reduction and select factor. Dimension reduction and select factor. Then what you need to do, you need to transfer all the variable from the left hand side dialog box to right hand side dialog box. So I just select, press Ctrl A, select all variables, and I'll transfer them to the right hand side dialog box. Okay, so now every variable is transferred to the right hand side variable box. Now you need to see the procedure. After transferring all the variable, just go to descriptive and select KMO and select KMO. KMO we are selecting for the purpose that we will check the assumption. So as you can see, it is written here, KMO and Bartlett test of sphericity. So these two tests will be used for checking the assumption of factor analysis. Okay, so it's done. I'll just press continue. And then go to extraction. Like I have explained, there are two steps. One is extraction, second is rotation. So we will do it one by one. So first we will go to extraction. Okay, in extraction you need to select the method. By default, a principal component is selected. It is the most common method which we use for exploratory factor analysis, so we will not change it. It is by default selected, principal component analysis. Okay, second is extraction. Either you want extraction based on eigenvalue or you want extraction based on fixed number of factors. Because we are doing exploratory factor analysis, we are not sure how much factors we need to create, so we will select this only, based on eigenvalue. In this case, the factor will be extracted based on eigenvalue. If any factor is having eigenvalue more than 1, then we will extract that factor, otherwise the factor number will be reduced. Okay, so now everything is sorted. Just click on continue. Okay, so before we actually go to rotation, we will check first the assumption, and we will check how many factors we need to extract. So these three things we will be checking before actually performing rotations. Okay, so I'm not clicking on rotation, just click on OK. Okay, so a few tables in the form of result is here with us. So first we will see this KMO and Bartlett test of sphericity. Okay, so first is KMO. KMO is just for determining whether sample size is adequate or not. It is also mentioned here, KMO, measure of sample adequacy. That means it is just for understanding whether your sample size is adequate or not. So thumb rule is, if the value of KMO is more than 0.6, then we consider that our sample size is sufficient. That means our sample size is significantly higher if the value of KMO is 0.6. So in our case, value of KMO is 0.84, which is higher than 0.6. So we can conclude that our sample size is adequate. Okay. Second, we will see this Bartlett test of sphericity. Okay, this test is just for the second assumption, which is a variable should be significantly correlated. Okay, so if the significant value of Bartlett test is less than 0.05, then we consider, or then we conclude that variables are sufficiently correlated. That means there are sufficient correlation between variables. That means second assumption is also fulfilled. Okay, in our case, significant value is 0.000, which is less than 0.05. Okay, which is the cutoff value. Okay, so now we can say that our variables are sufficiently correlated, so we can perform factor analysis. This is we have understood with the help of this KMO and Bartlett test. Now second thing, we have to check with the help of this total variance explained table. That means how many variables we need to extract, how many factors, sorry, not variable, how many factors we need to extract. That means these 44 variables, how much factors we can reduce these 44 variables. Okay, so this is very simple. You just need to look at this table, look at this eigenvalues. Okay, so in this column, just check the eigenvalues. If the eigenvalue is if eigenvalue is more than 1, we will extract only those factors. Okay, like in first factor, the eigenvalue is 7.2. In fifth factor, eigenvalue is 2.53, which is absolutely more than 1. Similarly, till 10th factor, till 10th component, if you can see, till 10th component, the value of eigenvalue is higher than 1. And after 11, after 10, that means from 11 onwards, the eigenvalue is less than 1. So we will only extract 10 components. We will only extract 10 components. We will extract 10 components. So it is also clearly mentioned in this extraction sum of squared loading. That means in this column, it is also mentioned that till 10th, the eigenvalue is higher, so we will extract only 10 factors. Okay, now everything we have checked. We have understood how many factors to extract. We have understood whether our assumptions are fulfilled or not. So just I am cancelling it. We will again repeat the process, and in this time we will also perform the rotation. Okay, So the rotation we will be covering in second part of this tutorial.